Like Scott said, my name is Kellan Elliott-McCrea. Until a few weeks ago, I was the CTO at Etsy. I'd been there for 5 years, helped grow and lead that team. And when I left, I wrote a blog post about the things I learned. And Chris Kelly from GitHub emailed me and said, hey, that was pretty good. Why don't you come talk at GitHub Universe? And I said, that sounds like fun. And he said, great. We want you to come and tell us everything you know about software development, engineering leadership, and everything you learned in the last 5 years. You have 20 minutes. And I said, that sounds fine. There'll be plenty of time for questions. I'm not actually going to take you through the whole blog post or quite everything I've learned in the last 5 years. I want to focus on just one thing I learned. And it underlies all of the work. There's sort of one theme that runs through that work. We're going to talk about the one true way to build software, which is curiously. And why I don't actually mean sort of strangely, I mean with an open mind. I want you to bring hypotheses, experiments, theses to be tested. Why? Why is that the right way to build software? Because we're really bad at it. We're really bad at it. And I don't mean I'm bad at it, or you're bad at it, or the people in this room are bad at building software, and someone out there has the right answer, and if we can just get them to tell us, we'll be enlightened. I mean, as a species, we are bad at building software. And this occasionally surprises people because some of us are good at writing code, and we tend to think it's the same thing, and unfortunately, they're not actually the same thing. I have some theories about why we're so bad at building software. I'm not going to linger on them too much. It's really more late night and hard liquor territory. But I do want to talk about sort of two contributing factors because it impacts how we think about software development as organizations. So first, software is hard. Modern software development is a complex, large-scale, fast-moving, improvisational, real-time, long-time scale, creative aesthetic endeavor. It's like a sports team or a band or a dance troupe had to get up every day, and instead of practice, we play. We get up each and every day, and we're on stage, and we're performing this large group creative endeavor. And we do it for months or years at a time, and we are judged by the entire output of the work over that time period. It's hard, and we don't have great models for doing it. We've tried industrial models, we've tried military models, we've tried not having a model, but it's hard. And the other contributing factor is the rate of change, and it's almost banal to talk about how fast technology changes in this industry. Almost. It never quite gets banal. But you know, we don't really internalize the fact that the rules of the game change 2 to 3 times a decade, if not more quickly. You know, fundamentally, the laws of physics change on us as we are trying to build software several times a decade. You know, think about architects who had to deal with new laws of physics building houses several times a decade. They would not be as good at building buildings as they are. And we haven't really internalized this fact. We're doing something incredibly hard, and the rules keep changing. Which brings me to Kellan's second law of software development. Your answers are wrong, or they will be soon. By the way, the first law of software development is never build a content management system. No good can come of it. So the questions stay the same. The answers change. And this seems like it may or may not seem profound to you, but it really is a fundamental shift in what we are trying to do as software development organizations. We are no longer in search of the right answer. We're no longer trying to find the right product or the right technical choice. We're now a team of people, creative, collaboratively, hopefully cognitively diverse, on a sort of continual voyage of discovery. No Gilligan Island reference in there. And that's a really sort of fundamental change in the work and in how we think about the work. And if I was clever, I'd just stop the talk there. I've said something sort of provocative, and I haven't gotten my hands dirty. But I have a little bit more time, so let's talk about actually how you do this as organizations. And I'm going to start off with 2 assumptions that I'm making, which may or may not apply to you. That build didn't work right. That's fine. First is you're here to make sustainable long-term change in the world. You know, whether or not that's out of a mission or just you think the world could work better, maybe you're trying to make a lot of money, it doesn't really matter. You know, you are trying to do something significant, and that takes time, and you need to survive to get to that significant change you're trying to make in the world. Sustainable long-term change. And you care about the thing you're building. It's important to you, whether or not it's an organization, a company, a product, an open source project. The what is important. So just 2 assumptions. If those don't fit for you, if you're sort of building a thing quickly to like flip it and sell it, I'm happy for you. I just have no advice for you. This is sort of the assumptions that I bring to this work. So we're building for the long term. And as a technology organization, building for the long term, it's not about stone and steel and cement and rebar and mortar and sort of strength and depth as an architect might think about it. It's about getting really good at change. Change is inevitable. We need to be good at it. And this is what long term means for us. You know, we're still stuck in sort of models of this as sort of a long term, unchanging in the face of time. That's irrelevant to the work that we're doing. Your culture needs to be a learning culture. Your software development organization needs to be a culture of learning. Great, boom, mic drop, problem done, enlightenment. No, of course not. You've heard this before. So how do we do it? That's the really interesting question. As software development organizations, how do we become learning organizations? Well, the first question is, what keeps us from being learning organizations? You know, there are some behaviors that keep us from being learning organizations. Culture is hard. You have to wake up every morning and decide you want to promote a particular culture. It doesn't happen on the side. It doesn't happen after hours. It doesn't happen at your Wednesday lunch and learns or brown bags. Culture is an ongoing set of activities, and it takes a ton of energy, and it needs to be your top priority if you're going to shape your culture. So first, let's talk about the things that hold us back from being learning cultures. Some of these may sound familiar to you. I'm just going to speculate. Firing people for making mistakes. Failing to hold people accountable for outcomes. Blaming failure on human error. Blaming forces outside of our control. No one could have foreseen it. Who cares? Thrash, frequent focus change or reorganizations. Teams that don't have long-standing trust and long-standing goals don't learn. Going off quietly in a corner and not shipping. I put my headphones on. I'll come back in a year. I'll throw the code over the fence. Great. Learning. No. Novelty. This is an often overlooked drain on learning in our organizations. We love new, shiny things in this industry, but if we solve each new problem in a new way, we don't get better over time. Also, underinvesting in our stack. The technology will take care of itself. I'm trying to build a business here. You might have a lot of free-floating new information in your system, but you're not learning if you're not reinvesting it. Optimizing locally. If you're not thinking about the entire organization in space, you're not learning. Autocratic decision-making. Just because the CEO made the decision, or the best engineer, or the loudest voice in the organization, if you allow that to be how decisions are made in your organization, you will not learn. Also, no one being able to make a decision stick. If no one can make a decision, learning is also not happening. And finally, assholes, and that's a technical term. Assholes are a major impediment to learning. So how do we support learning in a technical organization? I have this wonky slide that I use for internal talks. I actually don't think I've ever used it externally. Sort of 13 steps for learning with an engine of continuous deployment at the middle of it. We have like 11 minutes, so I'm going to do a simplified version of this. Sort of 4 key quadrants of behavior. This is still a cycle. This is not a checklist. You're not going to go 1, 2, 3, 4, boom, done. It's something you do over and over again. So you pick a quadrant and you go clockwise in your behavior. And you do it as you get better and better. Let's start off with confidently take risks. And in each of these sections, there's going to be the one key question you need to be thinking about while you're in that quadrant. So in this one, the question is, what is the largest single change you could deploy to the system you're building with near perfect confidence? For how many people in the room is there no change you could deploy with near perfect confidence? Handful of hands. For how many people are you confident that nothing you could do would break the system if you deployed it? Yeah, no hands. So everyone else is on a spectrum somewhere there. That wasn't a terribly good interactive behavior. And what do we mean by confidence? Confidence means not only that we're not going to break the system, but that we understand the impact. We understand the product impact. We understand the operational impact. We have confidence. And the second question is, what gives you that confidence? You get up every day, and you are, for those of you who are part of software development organizations, and I assume that applies to most of us, you get up every day and you make changes to your system, and something keeps you from running screaming from the room. And those are the things that give you confidence. And in a modern software organization, there are lots of answers to that question. There's tests, there's training, there's QA, there's monitoring, there's metrics, there's code review, there's ramp-ups, there's user studies. It could be that these changes are trivial, or they're routine. By the way, those 2 words are anti-patterns. Don't use them. But when Etsy started doing continuous deployment, we didn't trust our tests. We'd actually just RMRF'd them because they were flaky. And we didn't trust the code because we had inherited it from a bunch of people who were brilliant but insane. and we didn't have QA, and we didn't like our monitoring. But you don't have to have perfect tools to get started is the point of the story. We had 5 graphs. We built a little tool called StatsD, and we used it to graph 5 graphs. And that was sort of how many people were logging in, how many people were creating new items for sale, how many items were selling. I'm forgetting one. Oh, yeah, signups and logins. And the number of posts in our bugs forum. And those 5 graphs gave us pretty good confidence that we hadn't totally screwed it up with a deploy, and that allowed us to start moving forward. So that's confidence. And you make risky changes, you take more confidence. So a simple change, you have less confidence, but you have confidence and you take risks, because otherwise nothing else happens. So then let's move on to the second quadrant. We honestly reflect. So we made a change, and we had confidence in it, and surprise happened anyways. This is inevitable. Who here has deployed a change so trivial it couldn't possibly break something, and it broke everything? Yeah, there we go. For the rest of you, you should try software development. It's awesome. At Etsy, we have an award that we give each year, or they. I said I'm not there anymore. It's going to take me a while to stop saying we. It's called the 3-arm sweater, and it's for the person who most spectacularly broke the site in a given year. And for the last couple years, we've been really giving it to the people who most spectacularly broke the site with the most innocuous-seeming change. 2 years ago, an engineer, I think as sort of like a wrapping up at the end of the day, pushed a 1-line change to an IE8 only CSS file and managed to DDoS our entire web cluster with a sort of an infinite loop. It took us 2.5 hours to recover. It was awesome. So he had high confidence in that change, but we were still surprised by the outcome. So the question you're thinking about in this quadrant, and this is the hardest question to answer, by the way, is what is it about the environment in which you made the change that gave you false confidence? We don't think about this question. I did a thing, it broke, I fucked up, I'm human, whatever, I'll do better next time. Not useful. That's a lazy and unacceptable answer. There was something about the environment that made you think that the change you were pushing was going to work, and it was wrong. And so what we need to do is we need to figure out what about the environment is wrong so that we can change it. There are some practices that help with this question. 5 whys is one. Blameless postmortems is another. We've written pretty extensively about how we do blameless postmortems at Etsy. These are documented. I recommend checking them out on the internet. And actually, I want to talk about one particular type of surprise that we run into over and over again, which is surprises around detection. This is an interesting subclass of surprise. We're often surprised by how long a bug can exist in our system. How is it that that bug has been out there for 24 hours, 42 hours, 2 years? How is that possible? Are we amateurs here? Is this amateur hour? Nothing gets the CEO quite going like finding a bug that had been out there for 6 months. So surprise is inevitable. 100% prevention is impossible. And actually, counterintuitively, possibly, the sort of asymptotic approach to I will think of all possible ways this could break and proactively code around them leads to more complexity in your system and more breakage. But detection is a thing that's really worth investing in. Getting good at detection, getting fast at detection, getting to the point that you are very quickly surprised and you can respond to it is the engine that drives a lot of learning. It also drives sort of modern security practices, product exploration. Getting really good at understanding very quickly the delta between what you thought your system should be doing and what your system is currently doing is sort of the secret sauce from an engineering standpoint. So we've honestly reflected. And now it's time to take those reflections and learnings and reinvest. The question for this quadrant, what are the changes you can make to the environment you're operating in to increase your confidence to take risks? We want to get back to the point where we can move more quickly, do higher risky things, but do them with confidence. Do them in a way that we're not just throwing shit over the wall. We are not cowboys here, unless you herd cows, in which case I'm happy for you. But for the rest of us, we are trying to do this systematically. Risky, fast-moving, but systematically and building over time. So you took a risk, you got surprised, you've reflected honestly on that surprise, you now understand, and you are at a unique moment in time. Right now, you have perfect clarity about how to be a better software developer. This happens to you at almost no point in your career, and you have that perfect clarity over a very narrow range. if I hadn't deployed on a Friday afternoon when everybody else was already knocked off or at sort of Beer Friday, I might have gotten better feedback on how to do this. The graph was misleading. The tests are flaky. CSS actually has the potential to cause infinite loops in our precompiler. You have perfect clarity for a moment. And this is the time when you become a better software engineer. And you can invest in better tools and changing the environment in which you operate. It's the most impactful work you can do as an organization. You need to prioritize it. It can feel like yak shaving. It can feel like this is not the thing that we need to do to survive. But if you want to survive for the long term, if you want to build sustainable long-term technological impact, you need to not get crushed under the weight of the complexity that which you're dealing with. And this is how you do it. You prioritize this work. At Etsy, the rule was it got done in 30 days. If we got surprised, we had a post-mortem, we learned some things, those things got done in 30 days, come hell or high water. Peter Siebel, who used to work at Etsy and now is the lead engineer on Twitter's engineering efficiency team, which is a new team they just created, gave a great talk last week at Scale at Facebook called Let 1,000 Flowers Bloom and Rip Out 99 of Them, thinking all about how, over time, investing in tools, particularly for large engineering teams, leads to just massive wins. I recommend checking out the talk. He also did a nice write-up of it. So we've prioritized investing. This is the final quadrant as we teach. The reflection phase was painful. It's always painful until it gets fun. The investments phase was expensive. We were building a bunch of tools that had nothing to do with our core business. And so the question becomes, how can we afford to keep working like this? How can we afford this level of distraction? How can we afford to make ourselves better software engineers? That's not what we're here to do. So as an organization, so first, did it work? As an organization, can we move faster and take greater risks with confidence now? If no, we should go back and look at how we got here. But generally, you find the no in this is that we haven't taught it. I was surprised. I sat down with my small team. We made some fixes. And now there are two ways of doing things. This is classic. Now you have in problems. This is not how learning happens. In organizations, you need to be globally optimizing. The more and more solutions to the same problem actually undermines your confidence in your system. You need to invest the time in teaching. It's the only way you can afford to do any of this stuff. If each of you have your own sort of beautiful microservice flower of unique snowflakeness, you are not a learning organization. The practices and documentations and tools you build have to be high enough quality that everybody wants to use them, and you have to invest in making sure that happens. The question we ask in our architecture reviews is, great, so we now have two solutions for this. What is your plan for making sure that your solution kills and eats the other solution? Just in case you thought we were all hippies here. All right, and then you go to step one. You do it again, and you get faster, and you get better. And like I said, it doesn't actually matter where you start in this cycle. Pick where you are, invest over time, take the energy to make this happen. I've got 1.5 minutes left. This sounds a lot like Agile and Lean to some people. What's different about this is the goal. Our goal is to be a learning organization. If your goal is to be a learning organization, that is your #1 goal. You can't be compromising it with other things. Agile is a set of practices for increasing the success rate of software development. Lean is a set of practices for increasing the chance of finding a proper market fit. The practices look the same, that's nice, but the goals are very different, and you need to make sure that you know what your goal is if you're doing this work. So in summary, we're bad at software. Your current answers are wrong, and failure is inevitable. The best software is built over time by teams with learning cultures. You need to subvert failure. Thank you.